Today we're going to cover topic number 15, mixtures, and you can go ahead and add this under your table of contents. And that's topic number 15, mixtures, and today's date. You can turn to that next available page you have on the right-hand side. Question number 1, how can you tell if something is a mixture? How would we know? And a mixture is definitely a word we've heard before. It's an everyday word. We've definitely heard it before. You probably know what a mixture is. So how can we identify it using scientific terms? So a mixture means you have two or more different substances. You have substances that are going to maintain their individual properties. So if I start with, hydrogen and oxygen, it's going to maintain that. If I start with, something that's blue, it's going to stay blue. Whatever that means, it's going to maintain their individual properties. It's not going to change its properties. And these are just physically combined. They're just mixed together. They're not chemically bound together like they would be if it was a compound, right? When they were linked by the electrons. In this case, they're just physically hanging out together in the same room. So different substances maintain their properties and they're physically bound together. What's the difference between a homogeneous and a heterogeneous mixture? These are two types of mixtures. You might want to make a little T-chart like mine, homogeneous and heterogeneous mixture. We need to practice saying those two words. You can't say the H because they both start with an H. So a homogeneous mixture means it looks the same throughout. So like Kool-Aid or tea, coffee, it looks the same throughout. I can't look in Kool-Aid and say, there's the Kool-Aid and there's the sugar. I don't look at tea and say, here's the tea and here's the sugar, or coffee. I can't say, here's the coffee and here's the creamer. It all looks the same throughout. It's uniform throughout. If we have a heterogeneous mixture, it looks different throughout. I can see it with my eyes. I can tell that it's different. So something like Lucky Charms, where I could pick out if I want to eat a rainbow or I want to eat a unicorn or if I want to eat the cereal part, whatever, you can choose which part you want. So homogeneous, it looks the same throughout. Heterogeneous, it looks different. You can see the difference. So let's practice a little bit. Looking at this, we have a salad. What kind of mixture would this be? If you said heterogeneous, you are correct. Here we have a glass of lemonade. Yes, we can see the lemon, but if we're looking at the whole picture, can you see lemonade, water, sugar? No. So that would make it a homogeneous mixture. Okay, here we have several different dogs. If I could individually say these are all a different breed, that would make it a heterogeneous mixture. If here I said, look, these are 4 golden doodles, then there's the same thing. They're a homogeneous mixture, all the same. Question number 3, what's the difference between an element, a compound, and a mixture? So we've already learned about elements, compounds. Now we're adding mixtures into this mixture. So how do we know the difference between these? So an element, remember elements were a pure substance. You can't break them down into a more simple form. It's as simple as it can get. It's just that one thing, right? That would be an atom of oxygen. It's as simple as it can get. A compound, we have 2 or more atoms that are chemically bound together. And that's a key word here is chemically. They're not just lingering by each other. They're chemically bound together. We know that they form ionic and covalent bonds, and you cannot physically separate it. I cannot just tug on hydrogen and oxygen and pull it apart and get water. You have to chemically separate them. A mixture is just physically combined. They're just physically hanging out together, physically combined. They can easily be separated physically, doesn't have to be chemically. I would make sure I have these little examples in the bottom that will help you remember. These are some very common ways to demonstrate elements, compounds, and mixtures. So here you see elements is one individual singular object. You see the compounds, or you can tell they're linked together. A mixture here, you can see that you have opposite things just kind of stuck together, hanging out. Here will be your examples down here where they're mingled together would make it a mixture. So I would add these in as common examples so that you can see them. If